Hey there, CJ Math students, and welcome to Notes 2.9. So we have a couple exercises today. The first is we're going to use this graphic organizer to record what we know about positive and negative numbers and see if they have anything in common. So, for instance, positive numbers are whole numbers such as like 1, 2, 3. You could also do decimals, and fractions like this, percents, all positive numbers, right? Negative numbers are going to be whole numbers that are negative. So negative 1, negative 2, negative 3, etc. You can do negative fractions as well. And believe it or not, negative percents. Now, what do they both have in common? They're both rational numbers, as in they can be written as whole numbers, fractions, decimals, and percents. And we can do all four operations with them. So we can multiply, add, subtract, divide them. And that's about it. If you have anything else, go ahead and throw it into those negative, positive. So negative, for instance, we're talking about debt. We're talking about gains for positive, right? You could throw in other keywords if you want as well. All right, so exercise 2, absolute value. This is an important one. It's the distance from 0 on a number line. So these bars mean absolute value. So this says the absolute value of 3 is 3. Well, does that make sense? So if I go to 3 on the number line, it is 1, 2, 3 spaces away from 0. The absolute value of negative 4 is 4. If I go to negative 4 on the number line, it is 1, 2, 3, 4 spaces away from 0. So why do we think the absolute value of a number is always positive, right? Even if the number is negative. So we had negative 4 here, but it was a positive absolute value. And that's the reason. The reason is because space or distance on the number line is always positive. So again, no matter what, your absolute value is positive. So the absolute value of 5, the absolute value of 5 is equal to 5. And the absolute value of negative 5 is also equal to 5. Basically, again, all the absolute value is saying is how far away is the number from 0. And you wouldn't say negative 5 spaces, you would just say 5 spaces, right? The absolute value of 0 is 0. The absolute value of negative 1,000 is 1,000. All right? So let's compare the following using less than, greater than, and equal to. So negative 11 and 3. Now here's the important thing. The further left you go on the number line, the smaller the number is. So this is somewhat a confusing concept, right? Your brain always thinks, well, the bigger number has more values in it, right? But actually negative 3 is smaller than, negative 11 is smaller than 3, right? You want to ask yourself, negative numbers is like owing money, and positive numbers is like money that you have. So would you rather have to owe $11 or have $3? Obviously, you would rather have $3. What if I did negative 12 and compared it to a negative 15, right? Well, negative 12 would be right here. Negative 15 is further to the left. So negative 12 is greater than negative 15, right? You want to have less debt. This is a confusing concept, but again, the bigger the negative is, and I put bigger kind of in quotations, the smaller it actually is because it's further left. So let's compare the following absolute values using the same thing. So the absolute value of negative 7 compared to 3. So first of all, you actually have to do the absolute value first. So this is 7 compared to 3, right? The absolute value of negative 7 is 7. The absolute value of 3 is 3. And 7 is greater than 3. So just remember, do the absolute value first. Okay? So if I said the absolute value of negative 8 and the absolute value of -9. You might want to jump and say, well, -9 is further to the left, so therefore it's smaller. You have to do the absolute value. So its absolute value of -8 is 8. The absolute value of -9 is 9. So really, 8 is less than 9. Okay. So let's look at exercise 3 real quick. Says the Chicago Bears ran 4 plays from the 50-yard line. We'll assume the 50-yard line in this case is the number 0. So each of the 4 plays, the ball was given to Jordan Howard, the Bears running back. What is the sum in yardage of Jordan's 4 rushing attempts? So all we're going to do is use this number line to count forward and backwards. So Jordan first runs for 5 yards. So he ends up right there. That's the first play. On the second play, he loses 5 yards. So let's lose 5. 1, 2, 3, 4, 5. So he's back at 0 on the second play. On the third play, he loses 4 more yards. So 1, 2, 3, 4. So that's the third play. And on the fourth play, he finally breaks free and gains 8 yards. So let's go down here. 1, 2, 3, 4, 5, 6, 7, 8. So he ends up there. So adding all those plays together, sorry, this blue one for some reason did not show up. Adding all those plays together, the first, the second, the third, and the fourth, where he ends up is how much yardage he totally gains. So he gains 4 yards, right? So if he ran a 5th time, what yardage would bring him back to 0? So again, how would I get back to 0 if I rushed for a 5th time? And obviously that's -4, right? Because if I move backward to the left 4 times, I'll get to 0. That's the end of part 1.